and welcome to Tech to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Phil Tomssello.
Thanks, William. And thanks for everyone joining me today for another Tech to Tech session. It's our case study series that we're continuing with. I'm going to share with you a case study with a customer of ours, a manufacturer that had to establish some new process parameters for critical cleaning of PCBs. This customer is a manufacturer for the military, and they had electronics, fuses, and timers. These products, these components had critical cleaning requirements. And the manufacturer moved to a new solder paste, which ended up being a no clean. So there were residues that they weren't familiar with in their cleaning process that they had to address. And the solder paste material change really led to a demand for a much better evaluation of what they were doing up to that point in cleaning. And they had to make sure, of course, for the military that they had process parameters that would achieve a critical clean requirement from those PCBs. The manufacturer really, they had to completely clean multiple sizes of boards with varying complexity all at the same time. They were cleaning, they moved from an organic acid based paste material using DI water only in an old batch cleaning system. And of course, moved, as I mentioned, to a no clean solder paste with flux residues that were significantly different. And they were very difficult to remove with deionized water only. The electronics really had to be free of flux residue. They were conformal coating these boards when they were finished with them. So they had to keep that in mind. They also had challenges that they had to be mindful of with label degradation, and they needed shiny solder joints. So we know that without proper cleaning, if you have remaining flux that is underneath conformal coating, that's just going to cause intermittent failures. Dendritic growth, residues are just going to get trapped underneath there. Humidity, heat, expansion, contraction, those things over time are going to lead to failures. And of course, for the military in a critical clean scenario, that's wasn't acceptable. The process, as we start with almost every customer we have, is considering those important variables. What are the soils? Being the solder paste, right? We had to address the specific solder paste. We had to look at the substrates, the boards specifically, the components, the labels. We had to look at their production process. We had to look at their cleaning process, the machinery they were using, the batch cleaner, and obviously the cleanliness expectations. So KaiZen was able to set up trial parameters, and we were able to review the efficacy of the chemistry and really talk about the viability of the customer getting a new batch washer, because the batch washer they had was extremely old. It was outdated. So we tested several chemistries, and we're able to, from that, confirm efficacy and compatibility, right? Compatibility with labels, the ability to remove the flux residues. Obviously, it's going to work well on the components. And we're able to confirm, certainly, and make sure that the critical clean specs were met, good visual appearance on the solder joints. And that's the way we went through that process. Certainly, in coming up with a solution, KaiZen looked at the Aquinox 4727 as the leading option for them, based upon the flux residues, the critical cleaning requirements. As I mentioned, that's what was chosen for this specific project, this process, this application. And the initial process parameters that we kept in mind were in direct comparison with our chemistries in new process to their prior process with DI water, just as a comparative. And after many trials that we went through in our lab with our teams, we found that for critical clean criteria, the 4727 at 15% concentration was ideal. 23 minutes, wash at 140 degrees Fahrenheit. There was a second 9-minute rinse, 130 F, then a final 6-minute final rinse at 130 degrees F. And that got them to where they needed to be. Aquinox 4727, incredibly strong chemistry from an efficacy standpoint. Complete rinsing, great cleaning of an extremely wide variety of assembly materials, which is important, keep in mind, right? Compatibility works great with the components, with the coatings, and certainly provides, it's a stable chemistry, which is was very important to this customer as well. We recommended a new batch style machine. Certainly KYZEN works and is familiar with many different manufacturers of parts washers, and the customer reached out to many of them with their requirements, and they finally chose a new style batch machine that would meet their requirements. It was up to date, modern technology to make sure they could dial in these processes. And they purchased this machine. They implemented the Aquinox 4727 chemistry, and they were able to hit those critical clean specs. An interesting follow-up to it was after we helped the customer, the manufacturer, get this process in for their customer, we had some other discussions with them because they were looking for a way to simply and effectively get proportioned chemistry into their batch machine. And KYZEN, we manufacture a chemtroller, which is the very easy to install automatic proportioning pump. And it ensures consistent, simple proportioning of chemistry, of concentration. Certainly the manufacturer was happy they could install it very easily with our techs up there to do that. And it helps with their process. So we were happy to add that additional value for them. Again, just to conclude, the manufacturer for this case study, they did really well in obtaining the new machine, the new batch machine. They optimized the parameters with us with the 4727 chemistry. They were able to completely clean these PCBs that had all various technologies on them and sizes, and they were able to clean them prior to conformal coating, which was huge, right? They're trying to, at this point, shorten cycle times, but they've dialed in their processes and were able to meet the needs of their military customer. Several frequently asked questions come up. I'll address 3 of them here. The first one, why should I clean no clean solder paste flux residues? And frankly, despite the name no clean fluxes will leave leftover residues on boards after reflow, and removing this residue prior to conformal coating is extremely important. It's essential to ensure that these soils are not trapped on the board underneath that coating. Over time, it's going to lead to dendritic growth and mechanical failure, which certainly is unacceptable in a critical cleaning scenario like that. Question number 2, what are the key concerns in determining best cleaning processes? And, I think all successful cleaning really starts when you're looking at PCBs. Anything, quite frankly, is understanding the cleanliness expectations. And at KYZEN, we talk about how clean is clean. Well, in the electronics world, IPC class 1, class 2, and class 3 are important to keep in mind. When we say or refer to IPC class 1, 2, and 3, those definitions, quite simply, class 1 refers to a short life cycle, cheap quality. Toys are a perfect example of that. IPC class 2 is dedicated service electronics like microwaves and laptops, right? So longer life cycle, good quality. When we talk about class 3, of course, we're talking about high reliability, really fail-proof or very, very long life cycle, but fail-proof is very good to keep in mind. Of course, military, aerospace, medical. So the cleanliness and the best cleaning process really depends upon the complexity of the board, the cleanliness specs, and the other details and variables involved. So the amount of residue, you could say, that's left on a PCB relates directly to that broad range of cleanliness expectations that the customer has, or the willingness, let's say, for the user to pay for that level of cleanliness. The third question, how long does it take to dial in new process parameters? And candidly, the time needed to confirm a balanced cleaning process really depends upon the details of the conformal coating, the board components, then factoring in details of time, energy, solvency, and temperature. All those really go into dialing those process parameters. And sometimes they take uh, quite a bit of time just to make sure that we can examine all of those variables and make sure we have a very directed approach to get the best balanced cleaning process we can for our customers. With that, I'd like to turn it back over to William.
Thanks, Bill. Thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com. We will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.